Welcome to The Explainer. Today, we are absolutely diving into some seriously mind-bending theoretical physics concepts. We're talking about the cosmic boundaries and the quantum veil. These are ideas that will completely challenge your everyday perception of reality. Let's get started.
Section 1. Challenging Human Perception. Today's journey is going to take us right down a cosmic rabbit hole. We're actually bypassing a traditional agenda entirely just to plunge straight into the vast unknown. Okay, let's dive into this. Reality, time, the universe. You know, in our day-to-day lives, we pretty much take these three pillars completely for granted, right? We trust what our eyes see, we trust the steady ticking of our clocks, and we just assume the cosmos follows, well, intuitive rules. But as you'll see in the concepts ahead, these foundational pillars of our understanding are about to be turned completely upside down. Section 2. The silent universe. We are going to start out on the massive macro scale of the universe, and we have to face a really deep mystery about humanity's actual place in the cosmos.
So, if intelligent life is probable, why is the universe so silent? It's a massive cosmic dilemma known as the Fermi paradox. Think about it for a second. There are estimated to be tens of billions of potentially habitable Earth-like planets in our Milky Way galaxy alone. By all accounts, intelligent life is statistically highly probable. And yet, when we listen out into the stars, we hear absolutely nothing, just silence. It's kind of chilling when you really ponder it. Where is everybody?
Now, what's really interesting about this slide is how it presents a potential, albeit pretty terrifying, answer to that silence. It's called the Great Filter. Basically, this is a theoretical concept suggesting there's some sort of insurmountable evolutionary or cosmic barrier out there. Something that stops civilizations from advancing far enough to actually be observed by us. It is a sobering thought for sure, and it completely reframes how we look at the scarcity of life in the cosmos.
Section 3. The illusion of time. Okay, so we're zooming in from the lonely, silent edges of the universe, right down to the actual physical mechanics of space-time. And spoiler alert, the time you experience every single day, it's not absolute.
Here we encounter something called time dilation. This is the phenomenon where gravity and velocity literally slow down time relative to an observer. That means time physically bends. Let that immense concept just sink into your mind for a second. Time is not a constant. And hey, it's also a spectacular excuse if you're ever running late.
Now you might be wondering, is this just abstract math? Not at all. It has incredibly real, everyday applications, and this brilliantly illustrates the concept. Take the GPS satellites in orbit right now. Because they're moving at incredibly high velocities and they're experiencing slightly weaker gravity than we do down here on Earth, they literally experience time differently. The dilation is so significant that the atomic clocks on board these satellites have to be manually adjusted forward by about 38 microseconds every single day. If they didn't, they'd fall completely out of sync with our timeline here on Earth. Crazy, right?
Section 4. The point of no return. So, we've seen time dilate. Now we're moving to the ultimate extreme of space-time distortion, a place where the rules of physics are pushed to their absolute breaking point.
Here's a direct challenge to your grasp of cosmic extremes. In physics, what hypothetical boundary around a black hole marks the point of no return where escape velocity equals the speed of light?
So, the crucial point is that this boundary is called the event horizon. It's the definitive point of no return. Once anything crosses this absolute physical threshold, space and time warp completely beyond recognition. The escape velocity required to get out actually equals the speed of light, and since absolutely nothing travels faster than light, well, nothing escapes. Period.
Section 5. Spooky action at a distance. Now, we are going to zoom all the way down to the microscopic level to pull back the quantum veil and reveal perhaps the most mind-bending dilemma yet.
Enter quantum entanglement. This phenomena is just truly awe-inspiring. It's where particles instantaneously influence each other, regardless of the physical distance separating them. It completely shatters our standard human understanding of physical space. You could literally take two entangled particles, place them on completely opposite sides of the universe, and a change to one will immediately reflect in the other, effortlessly linking them across the void. No lag, no delay.
This concept was so deeply unsettling that Albert Einstein famously called it spooky action at a distance. And we really just have to fully embrace that mystery. At the quantum level, the universe operates in ways that completely defy our macroscopic logic.
To our everyday human senses, it behaves in a manner that quite literally resembles magic.
Well, we have taken a massive descent today. We started with the immense, silent universe and the existential dread of the Great Filter. We moved into the physical warping of time itself, crossed the crushing threshold of black hole event horizons, and finally ended up in the spooky, instantaneous connections of the quantum realm. Every single one of these cosmic dilemmas continuously challenges our baseline perception of reality.
Which leaves us right here with one final thought. If gravity actually bends time itself, and quantum mechanics makes a total mockery of physical distance, what else about our reality is hiding just out of sight behind the quantum veil? Keep questioning, keep learning, and I'll catch you next time.